Well, thank you for joining me today as we switch our training focus here away from individual products and to a more broader approach and something that Bell Performance is placing increasing emphasis on in the coming years, and that is the Bell Fuel and Tank Services program. And we will cover over the course of a number of trainings. We will be covering elements of the program, its components, and the value propositions of Bell FTS. And so for this time, we want to touch on some of the chemical solutions that can be utilized in the Bell FTS program, but not just in a standalone context, but within the discussion of how those chemicals fit properly within Bell Fuel and Tank Services. So with that in mind, we're going to start with a high-level overview of what Bell Fuel and Tank Services is supposed to be. What are the value propositions that it's supposed to offer to its customers? And as we'll see, an essential part of that are the fuel treatment chemicals that Bell Performance makes. So we will frame how those chemicals fit into the Fuel and Tank Services program, how the chemicals help fulfill the value propositions that Bell FTS offers. And this will transition us into an overview of the specific chemical treatments themselves. But not just, what are they and what do they do, but how are they best used within what Bell FTS does? What problems do they address that are targeted by Bell FTS? How are they, best used to solve those problems? Now, at its core, the Bell FTS program was created to address a growing need in the marketplace, and that need is the need for a multi-pronged approach to stored fuel management, an approach that cuts through the white noise of market confusion and gives stored fuel customers what they actually need for their fuel. And because of how the fuel landscape has changed, we're really starting to see that successful stored fuel management involves multiple things. Fuels are more environmentally friendly now, but they're also more susceptible to problems, which means you have to pay more attention to them. That by itself speaks to the need for actual fuel preventive maintenance, what we would call fuel PM. This means successful fuel PM has to involve things that people weren't used to needing to pay attention to in the past. Successful fuel PM has to involve a multi-prong approach, and we call that a hybrid approach to fuel management. That means that while certain things are important, no one thing by itself is the be-all and end-all solution for making sure that stored fuel health stays healthy. That means that people who are already really busy but who rely on stored fuel to accomplish important functions, those people have one more thing to worry about. The fact that they have to worry about all these new things with their fuel, and those new things, they might be things that those people don't really know that much about. So in a nutshell, this new multi-pronged best practice approach that's encompassed in the Bell FTS program involves chemical treatment, it involves mechanical processing, and it involves fuel testing. Now, a big issue is that the people who are, their operations people or their fuels managers or fleet managers, even if they recognize that there are things they didn't have to worry about before, but they have to worry about now, things they have to consider, things they have to add to their workload. A problem, though, is that, even if they try to find the answers to these new fuel problems themselves, they end up more confused than when they started. And part of that, part of the reason for that is for these people, fuel management isn't really their wheelhouse. They have to worry about fuel management because it helps them do their job, but they're not petroleum chemists. They're not fuels professionals by and large. And so another significant of the problem follows that when they go to try and find answers for what they're concerned about, they really don't know what to pay attention to. They don't know what's good information versus what's not viable information. There are lots of people out there, lots of companies out there. They're all talking, whether it's fuel additive companies or could be fuel polishers. There are lots of people like that who overpromise and underdeliver. They make unsupported claims about what's needed, and so there's a lot of white noise in the marketplace. And these fuels professionals, these operations managers, they need an expert who they can trust to tell them what they need versus what they don't. And that is where Bell Fuel and Tank Services comes in. So chemical, mechanical, and testing, the three prongs, the hybrid approach. How do these three prongs fit together? Well, mechanical processing, that's needed to remove things from the fuel in the tank that chemicals can't effectively remediate. Fuel testing is essential for several reasons. It helps define the problems, or as we would say, it gives you the benefit of a clearly defined problem. It also helps confirm if the problem has been solved once you take whatever action steps you decided to take. So you can see just from those two, you can see how those two things are important to have together. Without the right kind of testing, how do you know if mechanical fuel processing that is even necessary? Not to mention, how would you know if whatever you did was successful, or successful to the point where the fuel now meets applicable legal standards for its condition that it may not have before? So with mechanical processing, we know that it can help with certain things, but it cannot do everything. And that means that you need to use chemical treatments and mechanical processing together, not just one or the other. And so this brings us to the chemical solutions that are an integral part of Bell Fuel and Tank Services. So what we want to do here is we want to review each one, and while we will go over what they're designed to do and how they do that, we want to also discuss them within the context of how they're used in or as a part of the Bell FTS program. Now, what we mean by that is we're going to approach the discussion of these from a problem solution standpoint. Instead of saying, this is chemical X and this is what it does. Let's say we have a customer with stored fuel and they have a certain problem. The problem, we know that they have the problem. It's been confirmed by applicable testing. So it's not a question of if they have that problem. We know they have it. What chemical solutions would we recommend and would we typically use in such a situation? And then just as importantly, how would we properly apply those chemicals within the overall best practice solution steps that are advocated by Bell Fuel and Tank Services? So, first one, big one, water in the storage tank. One problem commonly seen all across the fruited plain is the presence of water in fuel storage tanks. Now, this water presence, if it's free water, then this will be detected when the technician uses water paste to stick the tank and assess the depth of any water paste present. Of course, once they do that, the first step, when we talked about best practice, the best practice would be then to remove as much of the free water as possible by mechanical means, because a free water layer is essential in helping microbial growth develop, and you do not want that. So the usual recommendation, depending on what other things are found, would be mechanically remove as much of the water phase as possible by when we say mechanically remove, that basically means pumping it out. Then it would be recommended to use a water absorber, which is DFS plus, to absorb whatever water may be left. Now, DFS plus is needed. That's a necessary step because if anyone has ever serviced a tank with water before, you know that it is really unlikely that you can get 100% of the water out of any tank because there are just things you cannot get around, like tank design, like it can have baffling. You may not physically be able to get to all the areas of the tank where pockets of water may exist. So you need something like DFS Plus as a water absorber to essentially help scavenge or mop up the remaining water. Now, DFS Plus itself, it only functions properly if it comes into contact with the water in the tank. So you would add it after you've removed the free water. You would add it to the fuel, and then you would circulate the fuel to enable or ensure proper residency time. Now, what if the problem is not free water? What if there's emulsified water in the tank? That's the other end of the spectrum. Many times you can have both free water present and then layers of different kinds of emulsified water, or what they will call a fuel water emulsion. You have that presence in the fuel as well. Now, we know that this is a bigger problem than it has ever been before, because we've got ULSD, ultra-low sulfur diesel, and also ultra-low sulfur diesel that has a proportion of biodiesel in it. And we know that both of those fuels have a greater affinity for water attraction than typical, what we would call high sulfur diesel. And so they have a greater affinity for water. They are more prone to forming fuel water emulsions. So this is a big problem, across the country, which means it is a great opportunity for Bell FTS to help a lot of people. So technician goes out and does fuel sampling, and they should be able to visually confirm that an emulsion is present. And once confirmation of that emulsion presence is done, then there are certain options we can consider. Now, some service providers at this point would choose just to do mechanical treatment. We're going to filter that. That sounds nice in theory. When they say that, what they mean is they're going to run the fuel through a coalescing filter. However, what they find is that coalescing filters rarely resolve fuel water emulsions, at least not without having to spend hours and hours and hours doing it, burning through lots of filters, which for service providers is a problem because you've heard the phrase time is money. Well, for them, that's 200% true. Time is definitely money for them. And they don't have time to spend hours trying to filter out an emulsion. So then, the appropriate recommendation via the Bell FTS protocol would not be mechanical filtration alone to try and resolve an emulsion. It would be application first of a demulsifier. In this case, either the formulation called demulsifier EB or tank treatment EB. Now, both of those formulations feature demulsifier, but what's the difference between them? Well, demulsifier EB, that product, is straight demulsifier, nothing else in it. It has a relatively low treat rate because it is just straight demulsifier. Now, Diesol Tank EB is the multifunction Diesol formulation, but without the water suspending surfactant, the water control package that it's traditionally had. Instead, that has been taken out, and it has been replaced by a demulsifier component. So, how do you use these? This is important to consider because, how you use or how you add demulsifiers is, pretty crucial to them actually working the way that you need them to work. So what you would do typically with a demulsifier is you would add it at the beginning. You could be added alongside other possible treatments like Belicide or tank treatment SDF. But you would add them together. Then, very importantly, you would circulate the fuel moderately, not circulate the heck out of it, as we might say. No, you would circulate them moderately, and then after you finished with that, then it would be important to wait for a period of time. That's because you have to allow the treated water to what they call to flocculate and to coalesce and drop out of the fuel. See, a demulsifier, the way that a demulsifier works is that you've got all these water droplets that have been are suspended in the fuel. Now, water typically is not soluble in fuel. Water is a polar molecule. Fuel is a nonpolar, just like oil, like vegetable oil. Oil and water don't mix. That's because oil is nonpolar, water is polar. So you've got two things that typically should not combine, and yet you have had, let's say, formation of natural surfactants, that things that are essentially enabling these microscopic little water droplets to stay suspended in the fuel. When you add a demulsifier, the demulsifier actually attacks those substances and essentially deactivates them. And thus it makes it easier for that water to fall out naturally, like it would normally. But it takes time for this to happen. So the demulsifier allows the water droplets to start dropping out. As they drop out, they'll bump into each other and they will coalesce. They'll get bigger. They'll combine. And as they get bigger, they start to fall out faster. So you add the demulsifier, you mix it, you wait for a period of time. How long do you have to wait? If it's in a lab setting, demulsification can happen in 15 minutes. But in the real world, depending on how big the tank is, you would typically wait 2 to 3 hours. So you wait 2 to 3 hours, and now you should see the formation of another water phase on the bottom, because that emulsified water has been turned to free water. Then the technician would continue their normal process. They would remove the free water that's formed, and then they would proceed with whatever other fuel filtration and fuel treatment that they were already slated to do. So it's very important when you're using the emulsifiers to allow them the time to work and to remove the free water that was formed before you continue with normal processing. Let me repeat that again. You have to remove the free water that was formed before you continue. The reason that is because if you then go to filter the water, what can happen is you can re-emulsify the water. See, a demulsifier is very good at doing what it's supposed to, which is breaking fuel water emulsions. But it has no functionality when it comes to preventing that water from going back up in the fuel. It's not supposed to. So you do need to treat that with a little bit of care and gentleness, so to speak. All right, so the next one, microbial contamination. Okay. Assessing and treating microbial contamination is a very important function for the Bell FTS program, given the universal seriousness of the problem that we see. Now, in the past, how would you confirm a microbe problem in storage tanks? Well, in the past, you would rely on corroborating information to piece together a most likely cause kind of case. Was there free water in the tank? Check. Have you been able to observe a change in the fuel's condition? Yes. Is there a rag layer, a layer of, biological matrix that is floating between the fuel phase and the water phase? Check. Have you been plugging filters at an increased rate? Check. All of these kinds of things are all correlating or corroborating phenomenon. Till recently, that was the best thing that you could rely on. You'd say, check, 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 check. You say, okay, it's probably microbes, and then you would proceed under that assumption. A few years ago, they started coming out with these indicator tests like dip slides or liquid cold bottles. And these are indicator tests that would give you basically a yes or no when it came to microbial presence in the fuel. Now, in this context, a yes or no is better than having to guess at it. So that's a step in the right direction. However, Today, we have something that's significantly better than even that. Today, as part of the Bell FTS program, we would use ATP testing to confirm problematic levels of microbial presence. ATP tests will give you not just a yes/no, but will tell you how many microbes are in there. Basically, it gives you a quantitative reading. Uh, ATP tests are quick to run and will give you results in about 5 to 10 minutes, whereas traditional dip slides you would have to wait 3 to 4 days. So you get results in 5 to 10 minutes. It gives you a quantitative reading, which means you can be a lot more precise in interpreting the conclusions and interpreting what your next best practice steps are going to be. So you do a test, you confirm that there's a microbe problem. The recommended protocol then would be to use, at the very least, to apply biocide, or better yet, biocide along with what we call a biomass dispersant, which in this case is tank treatment SDF. Now, typically, you would pair those two together because biomass dispersant actually helps biocide have increased efficacy. It helps it work better. Sometimes you will have a tank that has significant biomass present, and some of the microbes will live behind and in the biomass, and they will be shielded and protected from biocide application because the biocide can't get to them. But if you add a biomass dispersant like tank treatment SDF, it actually breaks up the biomass and helps the biocide to contact more of the microbes, giving you a more effective treatment. So, use of biocide and dispersant together. Fuel circulation and residency time. What that is talking about is, you as with many other kinds of chemicals, once you apply a biocide, whether you're using it with a biomass dispersant or whether you're using it with another kind of fuel treatment, fuel circulation is almost always recommended because that is really the best practice that helps get the biocide and the other chemicals properly dispersed and well mixed within the fuel. So you apply the biocide, you do fuel circulation, then you have residency time. What that means is that you have to then wait a certain amount of time and allow the biocide, allow the biomass dispersant to work, essentially. Depending on how much fuel you have, and depending on how serious the microbe problem is, it could take, it could take 3 hours, it could take 4 hours, it could take 8 to 12 hours. Sometimes they recommend for larger tanks waiting as long as 24 hours. Now, because all of this fits within the context of what we do in the Bell FTS program, there is always an element of what can you do. Ideally, you would want to wait. You could wait 24 hours. However, it's not always possible to do that because there are certain amounts of time that are allotted for service, service schedules, things like that. So the technician, in coming up with a service plan, will take all of that into account. But there does need to be at least some kind of residency time to allow biocide and other chemicals to work. Okay, what about excess sludge and particulates? That's a serious problem because fuels have definitely changed, right? Fuels, we have ultra-low sulfur diesel, and ultra-low sulfur diesel is inherently less stable than it used to be, and so there's a greater chance for fuels to form sludge, things like that. So excess sludge and particulate is a bigger problem than it ever was before, and thus it represents a great opportunity for Bell FTS to help more people. Now, how would you assess it? Well, sludge content in and of itself can be a little tricky to document because unlike water, it is difficult to detect through a method like tank sticking. I mean, with water, you can detect a free water phase fairly easily. You just use water paste. But there's no equivalent kind of thing that will tell you if you have tank sludge or how much tank sludge you have. So what the technician would probably elect to do is they would take some fuel sampling. They would sample from different areas of the tank because, as we know, fuel from the bottom of the tank may be different than fuel from the middle or from the top of the tank. So if he takes fuel samples and the fuel's dark and it has obvious particulate content, I mean, you just need to look at it, well, then that's a fairly easy assessment. However, if we're being systematic about this, we know that, relating this back to the whole testing issue, we know that the most accurate and legitimate assessment would be done by taking a fuel sample and submitting it to a lab to do a water and sediment ASTM test, which is the water and sediment test that is actually specified or spec'd in the ASTM D975 fuel standard. So you get that back, and let's say that the fuel comes back in excess of 500 ppm. Okay, 500 ppm is the legal cutoff. You're not legally supposed to have more than 500 ppm of water and sludge content in your diesel fuel. So it comes back. It obviously now needs some kind of remediation. And so what would you do? Well, to help treat the sludge and the particulate content, you would add tank treatment SDF first. You would add it, you would circulate it, give it some time to work, and then you would use high-quality fuel filtration to get the rest of it out. So, like we said, the SDF is applied early in the process before the fuel circulation because once it's in there, and then once you give it time to work, what it's going to be doing, it's going to be dissolving a proportion of those sludge components into the fuel, which is going to make the rest of it easier to remove, give you an overall more successful cleaning process. So this, what I just said, it's a key aspect to successful treatment. You want to vacuum out the sludge before you do filtration. Now, let's kind of clarify this a little bit because I've said a number of things and the exact process may not be entirely clear here. So let's back up a step and readdress it. Okay. First thing you do is you add tank treatment SCF. You circulate it. You give it time to work. And when you do that, it's going to be dissolving sludge into the fuel and it's going to be thinning out the existing sludge that's there. So then the next thing you do, okay, you've added SCF, you've circulated, you've waited. But now you don't do filtration immediately. What you do is you then vacuum out the remaining sludge that's in there. Then you do filtration there. So it's SDF application, circulation, wait, vacuum out sludge, and then filter. That's the basic process for remediating excess sludge and particulate. And then, of course, the last one would be you can take an after fuel sample and submit it for water and sediment test. And if everything's been done properly and works as it should, you're going to have a significantly lower figure there. Now, other Bell FTS chemical treatment options, Diesel Life, Diesel tank formula, Supertane, what would these be used for? These are fairly simple to use because they don't really require any special handling or administration instructions. Diesel Life is a fuel stabilizer. Diesel tank formula is a multifunction detergent cetane improver combination without any water control in it. And Supertane is cetane improver. Diesel tank formula also has stabilizer in it. And these are really simple to administer because you just add them to the fuel and you circulate. So typically what a technician would do is he would add these last. He would add these towards the end of his filtration process to allow kind of that last leg of filtration to be the circulation aspect that allows them to get mixed into the fuel. Um, so then he would, finish the circulation. Now they're mixed in, and now when he leaves, they're going to be in the fuel that's left behind, doing what they're supposed to do. So, as we start to wrap this up, we have to consider a couple final things. And this one's important. Given the recommendations that we've covered so far, what about situations where we have more than one product to administer? Do certain combinations of recommended treatments, do they change how each one is administered? Well, it's possible. Let's consider some possibilities. An important one is if they find themselves with the need to add demulsifier and biocide and sludge dispersion. So you have a tank that has a number of things in it. It's got emulsified water. It has obvious microbial presence, and it has sludge and biomass in it. So those are three problems that require those three chemicals used together. Now, you can recall that all three of these, demulsifier, biocide, and sludge dispersion, they all require a certain waiting period after mixing to allow them time to work, right? So part of the recommendation here would be you can add all three of them together at the start of the process. You circulate the fuel moderately, then you wait for 2 to 3 hours to allow all three of them to do their individual functions. Then you mechanically remove the free water and as much of the thinned out sludge and dispersed biomass as possible. Then you would continue with fuel processing afterwards. What about some of the other product combinations? What about if you have free water and then emulsified water on top? Well, you could use the FS Plus for the free water, and then the emulsifier to resolve the emulsion. However, that is actually completely the wrong answer. A little bit of a trick question. You would never use the emulsifier and DFS together, ever. That's because they have what they call antagonistic effects. That means they do the opposite thing. And that means they are essentially going to cancel each other out. You're going to get no benefit, and you're going to have you're just going to have wasted time and chemical. So in a situation where you have free water and emulsified water, which is actually fairly common, which one of those would you choose to use? Well, you would use the demulsifier because you're going to the demulsifier is going to break the fuel water emulsion, which is going to add to the free water, which you can then mechanically remove as much as possible. So, what have we covered in our time together today? Well, we started off talking about the overall value propositions of the Bell FTS program, being that it helps stored fuel users make the best decisions for them on how to best take care of their stored fuel. And this typically involves a hybrid approach to fuel management, chemicals plus mechanical processing plus fuel testing. Then we reviewed the various chemical treatment options that are typically used in Bell FTS, but we reviewed them from a standpoint of how those chemicals fit into recommendations for solving specific problems, along with a discussion of how to best use and apply those chemicals. And the most important takeaways from these product discussions and how they are applied, I think, concerns the need to allow the right amount of time for them to work. Residency time, very important, especially for Belicide and STF and the demulsifiers. Very important to allow them to work and have the effect that they're supposed to have. And then, especially concerning demulsifiers, there is the need to be cautious about using fuel circulation after they've been applied because you do not want to re-emulsify the free water that you've now got. So that brings us to the end of our discussion about chemicals used in the Bell Fuel and Tank Services program. If you have any questions, then by all means let me know. I'm Eric Bjornstead with Bell Performance, and we will see you next time.